Hey, and welcome back to Gaffer's Grinds. In a previous lesson, we learned that a standard solution was a solution in which we very accurately know the quantity of solute. So we're usually talking about grams of solute. So if we can very accurately measure how many grams of solute, and we know exactly what the volume of solution is that we're making up, we precisely know the concentration. Okay, because concentration refers to the amount of solute, the quantity of solute per the amount of solution. Now, if we accurately know these two numbers, grams and the volume of solution, then we have what we call a standard solution, solution that we very accurately know the concentration of. That was our definition. I'll say it one more time. A standard solution is a solution whose concentration is known very accurately. So in this video, we're going to talk about how we would do that. Now, this is a mandatory experiment on our on the Leaving Cert course, and this process or these steps that we're going to talk about how we make it is a very common exam question. Comes up in question 1 very often, and it's usually what 15 marks this explanation. So it's not something that's that difficult if you get your head around and practice it enough. All right, so we're going to jump into the procedure now. First thing we're going to need to think about is how we would measure out the quantity of solution accurately. Now, this here is a picture of a mass balance. It's called a mass balance. It's for measuring mass. Now, you guys have used one of these before, for sure, but just a quick reminder, that's how it looks like. I'm going to draw a diagram of it here. Nothing too fancy, a couple of boxes, that's all we need. It would have a screen on here to tell you how many grams you had. And what we would do in this experiment is we will put some kind of a tray for measuring out our solute. So I'm going to draw in red here. Now, sometimes the tray is plastic, sometimes it's glass. When we use glass ones, they're called clock glasses. Clock glasses, okay? Because old clocks used to have this curved piece of glass along the front of them that would protect the hands, okay? So the old clocks where the hands went around, they would have a curved piece of glass on the front, and it looked kind of like this, a curved piece of glass that we can then put our solute, weigh it out onto a clock glass. So however much you calculate that you need to measure out, the question will never really ask you specifically, but we'll weigh out our solute on a clock glass. Now, our solute can be anything, but we usually use a primary standard, something like sodium chloride or anhydrous sodium carbonate. So let's just call it solute for now. So we'll say we measure out our grams of solute on a mass balance. Okay, mass. All right, so we've got our grams of solute. The next thing we need to do is we need to start making a solution out of it. So we've accurately weighed out our, okay, so first of all, what would we say here if we were describing the points here? Well, what we would do here is we would write down the first point is what you actually did here. So you need the names of the equipment and the details of what you did. So mass balance, clock glass, and solute is what's important here. So you measure out your quantity of solute on a clock glass using a mass balance. That's it. That will be the step 1. What we have to do then is start making a solution. So we'll then take our solute, and what we would do is we would add it to a container. Now, the container we're going to use, first of all, here is just the standard container we usually use for holding liquids, and that is a beaker. So this here is a beaker. And again, I'm not going to show you a picture of that because everybody knows what a beaker is. All right, so you take a beaker and you add an amount of water to it. Now, obviously, whatever your final volume of solution is supposed to be, and in these experiments, it's usually 250 centimeters cubed, this first amount of water has to be less than that, okay? Because we're not finished yet. So we want to use a small amount of water, maybe 50 or 100 centimeters cubed. So a small amount of water in the beaker. Water is going to be our solvent, sorry. So we take our solute and we add it in. Okay, we take our solute and we add it in. So here's our clock glass, here's our solute. We're adding it in the solution. What we would then do is we would take this thing here. This here is a picture. Sorry, get my screen back for a second. Where am I? Take this piece of equipment here. This piece of equipment is a plastic squeezable bottle, and it's called a wash bottle. You can see here it's got this thin nozzle at the top where water can spray out of. So you put water in here and you squeeze the bottle and water can spray in out of here. and it's for washing and rinsing things. So we would then take a wash bottle. I'm going to draw it here, the small version of it. Take a wash bottle and you're going to rinse the clock glass. Rinse and make sure that the rinses go in here. Why would we do that? Well, remember what we're trying to do here. We're trying to make a very accurate solution. So we're trying to make a very accurate concentration, which means if we weigh out 10 grams, we need all of that 10 grams to be in the solution. So if we leave some behind, even a bit of dust on the clock glass, there's not going to be 10 grams. Maybe there's going to be 9.94 grams that gets, and that's not then a standard solution. So this is all about accuracy. So again, this will be important for step 2. What would we say? We would transfer the solute to a beaker of water, and we would rinse the clock glass using a wash bottle, and add it to the beaker. Now, I want to talk about the water here for a second. The water that we use in this experiment is what we call, sorry, I won't tell you what it's called yet, but basically what it is it's water that has been passed through a special filter which removes any ions from it. So water, generally it comes in the tap. It has been through, it's rainwater basically that comes in the tap. It's rained, it's gone down through some rocks, it's dissolved some minerals in the rocks, and it's got some minerals and ions dissolved in it. Now, those things might interfere with our standard solution and add extra ions into our mixture. So you're contaminating it, and you're also maybe changing the concentration ever so slightly because it might react with some of your solute. So if there's any ions in here, they might react with your solute, and then you don't have a known concentration anymore because you don't have the 10 grams of what you thought it was because it's reacted. So we use a special type of water here that has been passed through a filter, and this makes it deionized water. Deionized. So deionized literally means ions removed. So always in chemistry experiments, especially when we're talking about standard making solutions, we usually want to use deionized water for this reason. So it doesn't react with any of our solute. So this is important when we're talking through the steps. So the second step is to transfer the solute to a beaker, and then a beaker of deionized water, and then use a wash bottle to rinse the clock glass and add the rinse into the beaker. The next thing I'm going to add here is I'm going to add this here. What this here is, it's a piece of glass, and it's just what we call a glass rod. And a glass rod just allows us to stir the solution, to get it to dissolve, to mix it in properly. And we want to stir it until all the solute dissolves. So now we've got about 100 centimeters cubed, or however much we added in here, of the solution. Okay, now that's not the final quantity. Remember, we want 250, so we're not finished yet, but we've added to dissolve using a glass rod. What's the next step? The next step is we want to take this solution and we're going to add it to a flask like this. This here is a special flask designed for making up solutions very accurately. As you can see here, this one is designed to make up solutions that are 100 mils or 100 centimeters cubed. So these only do one, each flask only does one quantity of solution. If I wanted to make a different amount, I would need to use a different flask. So if I wanted to make 250 mils, I would need to use a bigger version of this flask. So there's only one place on this flask that we want to fill up the solution to, and that's this line here. This line is what we call the graduation mark. And what this does is it tells us exactly when there's 100 centimeters cubed here. This flask is specially designed for making solutions in, especially standard solutions, because this long, thin neck makes it very accurate. It's much easier to accurately measure when you have exactly the right amount in this flask than it is in, say, a beaker. A beaker is not. A beaker is really wide like this, okay? And the markings that, it does have some markings on it that tells you, 100, 150, 200. Beakers do have these markings on them, but they're not designed to be accurate because the beakers are so wide, they're not very accurate. So this here, this flask is specially designed to make solutions in. Its name is volumetric flask, a very important piece of equipment, volumetric flask. This is what we're going to finish making our solution in, okay? So what we want to do is we want to take a volumetric flask. I'm going to try my best to draw this. It might not be as nice as the picture. So narrow neck, and then a wide bottom. Okay, so there's your volume. Ooh, there's your volumetric flask. Okay, and on top, so we don't spill any, we're going to add in a plastic funnel. This here is funnel. And this here is a volumetric flask. Okay, so what we're going to do is we're going to take our beaker from over here, and we are going to pour in our solution. Okay, so we're going to pour in our solution into here. So we describe this process as transferring. We would say that we transfer our solution to a volumetric flask. And again, we'll talk about the size. Usually in these experiments, it's a 250 centimeter cube volumetric flask. We're going to transfer our solution or the contents of our beaker to a volumetric flask using a funnel, and the funnel just stops you from spilling. Okay. So once you've transferred, then you're going to use your wash bottle again. You're going to use your wash bottle to rinse out the beaker. So you're going to rinse out the beaker with some more deionized water, and then you're going to add the rinsings to the volumetric flask. Okay, so quite a lot of stuff going on here, and you have to remember each step in order, and don't forget about the details like the rinses. All right, the next step then is we have a certain amount of solution, however much was in the beaker, in the flask. So that might have been about 100 or whatever it was, but you're not fully finished yet. The next step that we want to do is we want to finish this off now. So using deionized water, what we're going to do is I'm going to mark the graduation mark in red here. Okay, what you're going to do is you are going to what we call top up the volumetric flask. So using deionized water, you want to top up the volumetric flask. We'll call this topping up. So top up with deionized water. Now, this is obviously a careful process, and I'll show you how to do this when we're really doing it. But this is a careful process because you don't want to go over the mark. Okay, you got to be very careful. If you go over the mark, then you've diluted the solution too much, and you can't take any out because that won't change the concentration. That just removes some of the solution. So you don't want to go over that graduation mark. So we top up carefully with deionized water. Now for the last bit, we need to be very specific. Okay, so how do we finish it off? I'm going to draw the neck here for a second. This is just the neck. Imagine that we've zoomed in on the neck, and here's the graduation mark. All right, we're zooming in. Now, what we're looking for with the water or the solution is when solutions are in a flask like this, especially when the neck is narrow, what they tend to do is stick to the glass on the outside and dip in the middle. So where they're near the glass, they'll stick to the edge. But when they're not near the glass, they'll dip in the middle like this. So see this curve that we get on the top of the solution here? This curve is what we call a meniscus. So the meniscus is the curve on the top of a liquid when it's in glass. So the meniscus is what we're looking for, and we're looking for the bottom of the meniscus, this point here, to sit on the graduation mark. So putting these two things together, we're going to top up carefully until rests on the graduation mark, or sits on the graduation mark. So the details about how you do this are very important, that we talk about them in our description. So we're going to top up carefully until the bottom of the meniscus rests on the graduation mark. Okay, all right. So now, once that's done, you've made your solution to the exact right volume. So what have we got? We've got a solution where we know the exact quantity of solute because we measured it out accurately. So it might have been 10 grams, 15 grams, whatever it was supposed to be, you measured it accurately on the balance. You then added it to deionized water and you made it up to an exact quantity or exact known volume. So what you've done is made a standard solution. Now, at this point, what will have happened is when you topped it up carefully, all this top part here will be water because that's what you added at the end. And all the solute will probably be down the bottom where you mixed in the beaker. So it's not properly mixed here. So the last step is about making this whole mixture equally, the concentration equally spread among the solution. So what we do here is we take a cap. So we put the cap on, I'll put the stopper, call this a stopper. We say put stopper on the bottle or on the volumetric flask, place stopper on the volumetric flask. And what we do is we turn it upside down. So literally turn the whole flask. So you put your hand on the bottom here, you put your hand over the lid, and you literally turn it upside down, up and down, up and down, up and down. This is called inverting. Okay, and what you'll notice is when you turn it upside down, all the liquid rushes to the bottom, and you get like air bubbles that fly up to the top of the flask, then, if you like. And then you just turn it upside down, does the opposite, up, down, up, down. And you want to do this invert about 20 times. Okay, and what this does is it properly mixes the solution. Let's take you through the whole process again one more time. Be much more quick this time. So step one is you measure out your solute, whatever it is, on a mass balance. Okay, so you use a clock glass to measure it out on a mass balance. What we then do is we transfer our solute from a clock glass to the beaker of water, of deionized water. Careful. Okay, so we transfer our solute to a beaker of deionized water, and then we use a wash bottle to rinse the clock glass, and we add the rinsings to the beaker. We then use a glass rod. So sorry, this here is number 2. This here is number 3, the glass rod. We stir to mix, stir to dissolve. Okay, so I'm going to put a keyword here beside glass rod. This is for dissolving. So dissolve, we stir to dissolve. Okay, number 3. What we then do is once it's dissolved, we then do number 4, which is we transfer the contents of the beaker to the volumetric flask. Okay, so transfer the contents of the beaker to the volumetric flask, and again we rinse the beaker and ensure that all the rinsings go into the volumetric flask. What we then do is we top up carefully. Number 6, we top up carefully using deionized water again, and we do this until the bottom of the meniscus rests on the graduation mark. So this is number 7. Okay, bottom of the meniscus rests on the graduation mark. And we put the stopper on, 9, and oh sorry, this is 8. Put the stopper on, and we invert 20 times to mix. All right, so hopefully that takes you through the process. Obviously, my drawings aren't very neat, but I think that they're good in that they're being drawn live in front of you rather than just putting up a picture. I'm going to show you a picture in a second that has all the steps, and maybe if you want to take them down, you do it from the ones that I have over here. But hopefully you realize that the one that I did drawing it live gives you a better understanding of it, in my opinion. It's better for you guys to learn than from a stationary picture. So what I'm going to do is I'm going to show you that stationary picture now. You guys have this in your book, in your essentials unfolded as well. That's where this picture came from. If it's not clear enough or you want to look at it a bit more closely, you can go there and find it. Okay, so here you can see again all those pieces of equipment and all those steps that we just walked through. If you want to make your own little copy of that, again, what is it called? It's to prepare a standard solution of sodium carbonate. That's the title of the experiment. Bits of this come up very often. Okay, so if you want to pause the video and make some notes or make some diagrams on that now. All right, here are the steps. I'm going to get you guys to pause and read through these now carefully again. Okay, why are some of the words in bold? So some of them are obviously highlighted in bold text like this way. These are the action steps that you really have to have in your exam question, in your exam answer. So when you're practicing exam answers, these are the target words that you really want to be getting in there. This is the key part of each of the steps. Okay. All right, so as it says here then, this procedure is asked about in detail very frequently. It's usually worth 12 to 15 marks. So pretty easy, 12 to 15 marks. Hopefully it's not one you'll forget. It's one that you're going to do at least once or twice during this during the course. You're actually going to make these solutions. Nothing hard to understand here. It's just something that you have to practice now and get into your memory. All right, so here are some questions for you guys to practice. Okay, so what I would like you to do is I would like you to pause the video and work your way through these questions now, please. Okay. All right, so you should only be playing if you've had a go at them. I don't think that there's anything that's that important, sorry, that's that difficult here. Just want to get you to really focus on 36 and 37. Don't give up when it gets to those. Those are the important ones for helping you to really understand why you're doing these steps and identify mistakes that can be made and mistakes that students talk about in exams. So don't give up there because that seems like a lot of work. It's not that much work, okay? But it's important that you guys do it. All right, guys, that's it. We'll again discuss the answers to these in class the next day. And we will be doing this experiment as soon as possible. All right, that's it, guys. I'll see you in the next one.